Okay, so we're going to be looking at standard deviation here, and we've looked at mean, median, mode before, measures of the center, and we've looked at range, measure of variation. Well, standard deviation is another way, in a sense, to measure variation, but specifically it's a measure of how much a typical number, a typical value in the data that we're given differs from the mean, okay? In other words, it kind of helps us evenly distribute how is the data spread out away from the mean, okay? Now, a symbol we often use is this guy, and that guy we would call sigma, okay? So anytime we're looking at sigma there, that represents the standard deviation from the mean, okay? Now, we'll kind of get into this guy later, okay? This is the equation we would use to find standard deviation, and we'll look at that in the next lesson in these examples here. But specifically, I just want to focus on the actual normal distribution that we've talked about before and how the data is spread out, okay? Now, a normal distribution we talked about before kind of looks like a bell curve, and we don't have anything skewed to the right or skewed to the left. Now, a specific way we can define this, it's a bell curve that shows how data is distributed from the mean. Okay, now the mean, there's different ways we can represent the mean. Sometimes, and a lot of times, you might see it written as x bar, this being x bar, okay, this guy here, or sometimes you might see it as this symbol here, okay. This also represents the mean in our normal distribution, okay. But there's different ways we might represent the mean, and then of course we talked about this guy's right here represents sigma, which represents the standard deviation, okay. Now, this is an example of a normal distribution, okay, where things are evenly spread out. And the way this lays out when we're looking at a normal distribution, the mean is the center of the of our normal distribution, okay? The center of our bell curve here, okay? So the mean is the center value, okay? Then standard deviation represents how far away we are from the mean, okay? So this is what these values are indicating. This would represent 1 standard deviation away from the mean, 2 standard deviations away from the mean, 3 standard deviations away from the mean, but it's in the positive direction. Okay, now if we go the other way, this is also 1 standard deviation away from the mean, but it's in the negative direction, 2 standard deviations away, and 3 standard deviations away from the mean. Okay, now what that allows us to see is how the data is spread out. Now, within 1 standard deviation, if we're just talking about 1 standard deviation away from the mean, we're talking about this data right here. This would be 1 standard deviation away in the positive direction, and this would be 1 standard deviation away in the negative direction. Most of the data, when we're taking any given set of data that forms a normal distribution, kind of like IQ scores, most of the data is going to fall within 1 standard deviation, okay? Now, within each one of those, okay, maybe I need to use a different color here, okay? Within each one of these, let's just use this color for this guy, okay? This amount of data would be 34% of the total data, okay? So this would represent 34% of the total data. On the other side, it would also be 34%, okay, but it's on the negative side. Now, altogether, though, that would be 68%. If we add 34% and 34%, 68% or the majority of the data is going to fall within 1 standard deviation of the mean, okay? Then, if we go 1 more standard deviation in the positive direction, this would be 2 standard deviations away from the mean. This part right here represents 13.5%, and then going 2 standard deviations in the negative direction, okay, in the negative direction, this would also be 13.5% of the data, okay? Then, let's see, let's go with, why not? Well, not that color. We use that color, this color. Then if we go 3 standard deviations away, this would be 2% from here to here would be 2%, okay? And then going here to here, this would be 2% in the negative direction, but this would be 3 standard deviations away. And then if we go past that, that's where almost none of the numbers would be. Let's use, maybe we'll use yellow, why not, okay? This would be 0.5%, and on this other side we'd have 0.5%, okay? Now, a good way to think of this, if you think of like IQ scores, the average IQ score would be 100. And then 1 standard deviation away in the positive direction is 115. 2 standard deviations away would be 130. And then if we go 3 standard deviations, it'd be 145. Okay? So that would be in the positive direction. Then if we go in the negative direction and we're subtracting, of course, we'd end up with 85, 70, and then 55, okay? So this is what a typical normal IQ, normal distribution would look like, where 100 is the mean, the average, and then the standard deviation for a IQ score, the standard deviation, or the sigma, is 15, okay? That's how it's spread out, okay? So if we look at an IQ score, or an IQ normal distribution, the mean, the middle number is 100, but the standard deviation is 15. That's how far apart each standard deviation is from the mean. So if I add 15, 100 plus 15 is 115. 115 plus 15 is 130, plus 15 is 140. Then if I go in the other direction and I subtract 15, 100 minus 15 is 85, and so on, okay? So that would be a good example of how a normal distribution is spread out, okay? Now, within that, if we want to look at the percentage that is 1 standard deviation away from the mean, okay? So remember, we said 1 standard deviation away is both in the negative and in the positive. Well, we said this guy contains 34%, okay? This guy contains 34%. So altogether, 1 standard deviation away, whether it's in the positive or the negative, 34 plus 34 means that 68% of the data, maybe get rid of this guy right there, 68% of the data, 60% of the numbers falls within 1 standard deviation, okay? Or a good way to think of that IQ test. 68% of the people that you would normally select for a normal distribution curve and an IQ test, 68% of the people would be somewhere between 85 score and 115, okay? If we're going 2 standard deviations away, well, then it wouldn't just be that. Now we're talking about this guy, this guy, this guy, and this guy. Because notice, that's 2 standard deviations away from the mean. So now we're talking about the 68%, but we're also including scores 13.5 and 13.5, okay? So if we're 2 standard deviations away, here and here, we have 34% in the positive direction plus the 34% in the negative direction. Then there is 13.5 in the positive direction plus the 13.5 in the negative direction, okay? So altogether, the amount of people that fall within 2 standard deviations here, if we add that together, we're going to get 95%. So 95% of the people would fall within 2 standard deviations, okay? Now, if this is kind of getting a little cluttered with the color, maybe we can kind of go back here. So what we were saying is if we're in 2 standard deviations, this would be 2 standard deviations. So 95% of the data falls within this range. Or you might think of it this way. If we're looking at an IQ score test, 95% of the people would be somewhere between an IQ of 70 and an IQ of 130, okay? Now, if we're going 3 standard deviations away, if we go 3 standard deviations away, then that would include all of this, 2 standard deviations away, and 3 standard deviations away. Then we're going to add in 2% and 2%. So we'd add in 2 and 2. So adding 2 plus 2 to what we had before, that's 4. 95% plus 4 gives us 99%. Okay, so 99% of the people would fall within 3 standard deviations. Or like I said before, another way to think of it, if you're looking at a normal IQ test, 99% of the population would have somewhere between an IQ of 55 and 145. Okay, so that's what this is talking about here in terms of standard deviations and how things are spread out. So most people are within the 68%, 1 standard deviation away. Then if you go 2 standard deviations away, that's 95% of the data. And then if you're going 3 standard deviations away, that's 99%. Okay. Then of course, if you go to 4 standard deviations, you're probably hitting pretty close to 100%. Okay. So that's how things are spread out. Now the way we can use that is we can use that to help draw a normal distribution, a bell curve, to help represent a certain situation and represent what percent of the data we're looking at, depending on how we spread things out based on the standard deviation. So like in this example, it says the grades of a statistics midterm are normally distributed with a mean, that's the center guy, and a standard deviation of 5. That's how far we're going to spread things out. Okay, so the best way to start this is kind of drawing our bell curve. And underneath this bell curve, we're going to write out how we're going to divvy things out, okay? The mean is always going to be the center, the middle of our normal distribution, okay? So in this case, our mean, our center number here is going to be 81. And the standard deviation tells us how we're going to space things out, okay? So 1 standard deviation away in the, maybe I just need to make a straight line here since it's not going very well. There we go. 1 standard deviation away in the positive direction is going to be 5 more away from the mean. So 81 plus 5 is 86. So 1 standard deviation away from 81 is 86. Going in the negative direction, we're just going to take 81 and subtract 5. So what's 5 away in the negative direction? Well, 81 minus 5, we get 76. Okay, so that would be 1 standard deviation away in the negative direction. Well, let's go ahead and see if we can kind of go out to 3 or 4 standard deviations. So 2 standard deviations away, I just need to add 5 to 86. 86 plus 5, we get 91. Let's go one more. 91 plus 5, we get 96. Okay, so if we're looking at this, this would be 1 standard deviation away, 2 standard deviations away, and 3 standard deviations away in the positive direction. Then going the opposite way, it's the same idea except we subtract instead of add. So 81 minus 5 was 76. 76 minus 5, we get 71. And then 71 minus 5, we get 66. Okay, so this is also 1, 2, 3 standard deviations away. It's just going in the negative direction. Okay, so this would be our normal distribution. And again, the percentages still remain. 34% will be in here. Another 34% will be in here. Then we have 13.5% in here. 13.5% in here. 2%, 2%, and then about 0.5% and 0.5%. Okay, so with that in mind, it says what percent of the data is between 76 and 86? Well, 76 is here, 86 is here. They're both 1 standard deviation from the mean. Well, what did we say earlier? If we're 1 standard deviation away from the mean, that's 68% of the data. So, what percent of the data falls between 76 and 86? 68%, okay, because they're 1 standard deviation away. Next question says, and maybe I need to get rid of these marks. Okay. Next question says, what percent of data falls between 71 and 91? Well, 71 is here, 91 is here. Notice they are 1, 2 away, 1, 2 away. They're both 2 standard deviations away from our mean here, okay? So if we're 2 standard deviations away, like we said here, if we're 2 away, that's 95% of the data, okay? So 95% of the data is going to be between 71 and 91. Okay. The next question says, what percent of the data falls between 81 and 91? Okay. 81 and 91. Well, 81 is our mean, and 91 is 2 standard deviations away in the positive direction, okay? So that includes this 34% and this 13.5%. So we have to add our percentages together to know how much of the data lies within 81 to 91, okay? So take 34 plus 13.5, and that's going to tell us the percent that falls within 81 to 91. Okay, so adding that together, you can do it off to the side or in your calculator. You should get 47.5%. So 45% falls between 81 and 91. Then the last question here says, what percent of the data is less than 86? Okay, well, looking at getting rid of our marks here. Whoops. I didn't want to get rid of that. There we go. Looking at this, 86% is right here. Okay? That's 1 standard deviation away in the positive direction. And they want to know what percentage is less than 86. So that's everything to the left here, because all of this is less than 86. So what percentage of the data contains all of this mess? Okay? Well, going back here, notice there's 34%, 34%, 13.5, 2, and a half. Okay, so we need to add all those values together to figure out how much of the data lies on this side. Okay, so taking your calculator or writing it off to the side and adding it, add that together, and we should get 84%. Okay, so 84% of the data lies within this region. Okay. So that's how we want to interpret the normal distribution, how things are spread out from the mean and then the standard deviations. Okay?